Okay, so our journey continues. Welcome to my channel. Yeah, please continue subscribing, continue watching, invite your friends. Yeah, let's continue revising together. So for today, I think I'll end with 3 for some reason. For some reasons, 3 it uses the method is a bit longer, so I think I will have to make a separate video for it. So for today, I'll just solve 6 and see if we can solve even 9. So 6 minus 3, okay, dx. So for this one, we can directly deploy the quotient rule. Yeah, because the powers of x are nearly the same, so we can't use substitution. Yeah, so we just employ the quotient rule. So quotient rule again, u over v is u prime v minus v prime u over v squared. Okay, so u is a numerator, so we say u equals to natural log x minus 3. So u prime. So if you differentiate this one, if you differentiate 1 over derivative of a minus the linear function. Yeah, let's say, if you remember from partial fractions, we had fractions like functions like this. For example, x minus 2. So the integral of this is ln x minus 3. So if you differentiate this, it will give you this. So it's the opposite. So du dx over the ln function, this will just be 1 over x minus 3, the opposite of the integration. So integration is telling you this. If you differentiate this, it will come back to this. So this will be 1 over x minus 3. Okay, so v equals to x minus 3. So v prime is, you differentiate this one, it will be 1. Differentiating this one will be 0. Okay, so we rewrite now. We deploy our formula. Our formula is integrating u over v equals to u prime v minus v prime u over v v squared, sorry. So u prime is 1 over x minus 3. This is u prime. Then v is x minus 3. Okay, minus, what is v prime? V prime is 1. And then what is u? U is ln x minus 3. Okay, so then over everything over v squared, so it's x minus 3 squared. So this is equals to, this and this will cancel, so you have 1 minus ln x minus 3 over x minus 3 squared plus c. Okay, so this is your answer. So integrating okay, let me see again. Okay, integrating x minus 3 over x minus 3 dx equal to 1 minus h log x minus 3 plus c. Okay, so this is your part. Is it what part is this? We've lost count. Okay, part 6. Okay, so now let's go to part 9. Let's solve 9. I think we still have some time here. Okay, so let's see. Okay, so part 9. So part 9, so we integrate cos ln x dx. Okay, so even in this one, the simple method here is just to apply the quotient rule. So the quotient rule, let's see, can we use a quotient rule here? The quotient rule doesn't seem to work. Okay, so because we have it will be a bit complex, we will deploy a quotient rule. So I think the best way is to use substitution. Yeah, so let's see what substitution can do. We'll say, of course we know this violates our earlier discussion to say the powers of x has to have a difference of 1, but in this is the special case. So we'll say u equals to here, what is inside the brackets here, so we'll say ln x. Okay, so meaning if we differentiate with respect to x, du dx, differentiating ln is 1 over x. If you remember, integrating 1 over x to give you ln x. If you differentiate, this will give you 1 over x. Okay, so this will give you 1 over x. Next, what do? We make dx subject of the formula. So we say cross multiply this by this by this. So this multiplied by x, this multiplied by that one. So x du is equals to dx. So cross multiply this by this, like that. So we're making dx subject of the formula. So dx is equals to x du. Okay, so now we substitute in our equation. Let's substitute where there is dx, we put x du. Okay, so this is equals to integral cos. So ln x, we've said this u. We use substitution method over x. Then where there is dx is what? X du. So x and x will cancel out. So let me continue from here. So this will be cos u du. Okay, so you know the integral of the cosine is just sine u. Oh, oops, why did you need to write? Use writing du, sorry. Okay, so sine u plus c. Then we substitute now. So we say integral of cos ln x over x is equals to sine, what is u? U is ln x, plus c. Okay, so this is your answer. Okay, so now I'm only remaining with one question to go, so that one I'll create a video for itself because the process is a bit longer. So thank you for watching. Yeah, so continue liking, subscribing to my channel.